Okay, welcome to our lesson today about angles and angle measure. We're going to be doing some conversions from radians into degrees, and then also from degrees with decimals into degrees, minutes, seconds. So just a couple of different ways to look at angles. Okay, let's talk about quickly. We've done this before. It's kind of a little bit of a review, but the quick conversion, 180 degrees equals pi radians. So if you use that equality there, we can usually use ratios to convert into degrees and radians. For me, that's usually the easiest way to do it with like cross multiplication. So for example, number 1 here, what I usually do is go 180 degrees equals pi radians. Well, degrees is 180, and this is in degrees, so I would put this under the degrees here. So we want to know how many radians is in 325 degrees. So again, we're just doing a proportion. What we're saying here is, let's use lightsaber. We're saying that if 180 degrees equals pi radians, then how many radians are in 325 degrees? So what we can do is we can cross multiply here. 325 times pi equals 180 times x. So I'll do this right here. 325 times pi equals 180 times x. To solve this for x, we divide by 180 on both sides, and we get x equals 325 pi over 180. So it would be 325 pi over 180. Well, that can be simplified. We can do that by dividing first by 5 maybe, just to break down, because we want it in terms of pi. So if I divide both by 5, so let's actually do divide by 5, divide by 5. It gives me 65 pi divided by, and then 180 divided by 5 is 36. I don't think those have any common factors. 65 goes into, let's see, what's 65 divided by 5? 13, no. So those wouldn't have any common factors. So that would be the answer. Okay, number 3, let's look at that one. This one, we are already in radians. It's telling you that because it has a pi. It's interesting because this was a negative, which doesn't really change the conversion at all. It's just saying that we're going backwards on if we started at our x coordinate. So, or x-axis, sorry. So let's just do this. I'm going to do the same exact thing. 180 equals pi radians. Well, now this is in radians, so I'm going to put this below the pi sign. Oops, let's do -4 pi over 3. And we want to solve this for x here. Obviously, you might need a separate sheet of paper for this. So we're going to do the same thing, and I'm going to actually move it over here. Cross multiply 180 times negative 4 pi over 3 equals pi times x. When you multiply here, cross multiply. Divide by pi on both sides. X equals. Now, since this is 4/3 pi, 4 pi over 3 is the same as 4/3 pi. There's a pi here, and then we can actually cancel these. So let's see if I can do this in my head here. 180 divided by 3 is 60. 60 times negative 4 is negative, let's see, that would be 240. That's it, in degrees. Okay. So this next part we haven't talked about at all in terms of decimal degree measure into degree minute seconds. Okay, so with this degree minute seconds, think of it this way, like on a clock. So if I have, and again, think of time here. If I said 1 hour, let's actually erase this real quick. If I said 1 hour, 37 minutes, and I don't know, 41 seconds. This could be 1 point something hours. And if I were just to guess, I'm just put a little guess over here. Guess. Well, 1 hour is 60 minutes. So 37 minutes. So 37 minutes will be about 0.5 hours. 40 minutes will be 40 out of 60, which is 2/3, which is 0.66 hours. So 37 minutes is probably like 0.6, right? And then this out of minutes is like 2/3 of a minute, which is another 0.66. So you might have like 1.63 or something hours is 37 minutes and 41 seconds. So if I were to solve this, if I were actually to do this 1 hour, and it's the exact same thing as you would do in decimal, because in decimal, because you're talking about a circle pretty much with degrees, you basically have the same, that 60 seconds are in a minute, 60 minutes are in 1 degree. So let's start at actually number 8 here. You're basically going to take each one of these little sections and convert them into a decimal first. So 57, for example, 57 would be 57 divided by 60, because there's 60 seconds in a minute. And then if you did that, we're going to go ahead and just divide 57 divided by 60. So 57 divided by 60, 0.95. So that's equal to 0.95. So now you have 232 degrees, 7.95 minutes. Well, now 7.95 minutes, we take 7.95 minutes divided by 60 to get a decimal in degrees. So 7.95 divided by 60 is 0.1325, which means it'd be 232.1325. That's degrees. So that's how you would go, it's called DMS, degrees, minutes, seconds, into decimals. Okay? Well, how do you work backwards then? And again, just a kind of reminder, recap here. All I did was took the seconds divided by 60 to get my minutes. I tack this decimal onto the end of my minutes. Now I have 7.95 minutes. I divide that by 60 to get the decimal in hours, which would actually be degrees here. 0.1325 degrees is this in minutes, and then tack that on to the end of degrees. Okay, now go the opposite direction here. I'm going to take 0.77 and I want to change that into minutes and then seconds. Okay, so we're going to work backwards. Instead of dividing by 60, we're going to multiply by 60. So if I do, again, I already have 128 degrees. So I'm going to take 0.77 times 60. And that's going to tell me how many minutes. 0.77 times 60, 46.2. Well, now I have my 46 minutes. Minutes is the one up there. But now I still have the 0.2. So now I just take the 0.2 and multiply by 60 to get my seconds. 12. So that would give me 12 seconds. Okay? Let's look at the next idea here. Okay, this one actually should be relatively easy. Find the measure of each angle. I'm okay if you put this into, if it's in degrees, keep it in degrees. If it's in radians, keep it in radians, but also you can make it into degrees also. So for example, on number, let's look at number 13. 13 here, we're going backwards. That tells me it's negative. Okay, now, if you went from here to here, well, that would be a negative 180. But since this is 20 degrees here, that means this has to be another 70 degrees because it's 90 to get to the y-axis. So negative 180 plus the negative 70 would be negative 250. Done. Okay. Let's look at, say, 14. This one we're going around once. And then we're going another distance here. Now, if you go around once, it's 360 degrees. But I'm going to keep this in pi form. So since 180 equals pi, that means 360 equals 2 pi. So to get to here, this is already going around negative 2 pi radians because you went around the circle once. But then you're going this additional distance. Now, I'm better at thinking in degrees. And pi over 3 is the same as 180 divided by 3, which is 60 degrees, which means this over here would have to be 30 degrees. And if that's 30 degrees in pi, well, 30 degrees is 180 divided by 6. So this is the same as pi divided by 6. So we're adding on another pi divided by 6, pi over 6. So it'd be 2 pi plus pi over 6. Now, if you want to get this perfect here, we have to have common denominators to add these together. So 2 pi over 6 2 pi is in 6 would be the same as 12 pi over 6. See, 12 divided by 6 is 2 plus pi over 6. So the final answer should be 13 pi over 6. So we added 12 pi plus 1 pi equals 13 pi. So as you can see, like doing these measures, you're going to be dealing, especially in radian mode, you're getting a little fraction reminder work. Okay, lots of types of problems here. Draw an angle with a given measure in standard position. So this was not, you don't have to be perfect on this. As long as you're in the right quadrant and I can kind of tell which axis you're closer to, that's fine. So for example, let's look at 18. 7, 10. So if I went around once, that's 360. Twice would be 360 times 2, which is 720. So I need to back off 10 degrees there. So all I need to do is draw something like that. That would be 710. Maybe put a 10 degrees there. That way I know. 710. Okay. Let's look at 21 here. I'm not sure if I get a little bit of room there. Negative 10 pi over 3. Okay. So when I look at this, I think, okay, 6 pi over 3 is equal to 2 pi. Okay, so, and then 12 pi over 3 is equal to 4 pi. 4 pi would be 2 times around. 2 pi is 1 time around. So if I started here and I went, I'm negative, remember I'm negative. So negative 2 pi. And then I go around again, that would be 3 pi, which is another 180 degrees. So 3 pi, if I were in thirds, would equal 9 pi over 3. So 10 pi over 3 would be another pi over 3. So pi over 3 equals 60 degrees. So if I just go another 60 degrees, then that would be the same as negative 10 pi over 3. And the idea here is that you have this angle, which is negative 10 pi over 3. Well, that's equal to a lot of angles depending on how many times you go around. And in fact, it's an infinite number of angles. If I started here and I just went this way in degrees, that would be 120 degrees. So the final position of negative 10 pi over 3 is the same as the final position for 120 degrees. And 120 degrees is 2 pi over 3. So it's the same as 2 pi over 3. So there's a lot of ways we can talk about that final position, but that's what they're looking for, just be able to draw it at that spot.